Welcome to the 80th lecture of Digital Electronics. In this lecture, we will be dealing with latch. Now let me explain what is meant by latch. Okay. So coming into latch, or this latch is also known as unclocked flip-flop. Unclocked flip-flop. Now, what is the word meaning of latch? Latch means lock. Okay. So, in digital circuit, what is meant by a lock? Lock means this output or whatever is the response, of the sequence circuit. It will be locked. To 0 or 1. Okay. That means if the output of a circuit is locked to 1 or to a 0, then such kind of circuits are known as latches. Okay. Now, basically there are two types of latches. First one is active high latch, and second one is active low latch. Okay. So here what we are going to do is we are going to put a lock. Okay. So what is meant by active high latch? This is meant by active high latch. That is the next question, right? Now coming into active high latch. Okay. So before going into this active high latch, let me explain what are the two types of inputs to a latch. Okay, I think that is better. Okay, before going to this active high latch, okay, let me explain what are the two inputs. Okay. Now, what are the inputs to a latch? Okay. There are two types of input to a latch. One is, say here we are having a latch, let it be a black box right now. We are having a set input, and a reset input. We are having two inputs, that is set input and reset input, and there are two outputs. One is you are having output, and second one is complement of the output. Okay. Now, if set is equal to 1, what you are doing is actually output is set to 1, and if reset is 1, what is happening? You are setting your output to 0. Okay. Now, so that is basically a latch. Okay. So latch means you are having a set input and a reset input. Okay. Now, if you are considering it as a black box, you are having set input and reset input, and there are two outputs. One is the original output, and second one is the complement of the output. Now, coming to what is active high latch. Here what happens? Here set and reset will be initially 0. Initially that is equal to 0. Okay. That is initially it will be at low state. Initially set and reset is at 0 or at low state. Now, one of them, that is one of set or reset is made high. Okay. If one of them is made high, then what happens to? Then output will get changed. So that is known as active high latch. Here I have given that. That means if set is equal to 1, output is set to 1, and if reset is equal to 1, output is set to 0. Now next one is active low latch. Active low latch means initially set and reset. Initially set and reset is 1. Initially it is 1. and if one of them is made low, if one of them is made low, that is made to 0, is made low, then output will get changed. Then output will get changed. That is in this case what you can, in this case, that is active low latch, what you can have is when set is equal to 1 you can make output as 0, and when reset is equal to 1 you can make output as 1. Okay, so you can take this as for this is for active high latch, and this one is for active low latch. So you can take it for active low latch. Okay, active low means when set is equal to here when set is equal to 0, here set is equal to 0. Okay, so here when set is equal to 0 you can make that means initially it will be high, and when it is made to 0 output will become 0, and when the set is equal to 0 output also becomes equal to 1. Okay, so that is a basic difference between active high latch and active low latch. Now coming into now I think you have got some idea about what is meant by latch. Now I am going to explain about a basic latch. Okay, basic latch means I am going to put a lock. How you need to put a lock? Now I need to lock between output and output bar. Okay, that is my intention. So for that I am going to explain a very simple circuit. Okay, so initially I will explain active high latch. Initially I will explain the operation of active high latch. Okay, so you having S as an input, reset, that is S stands for set, here S is set, and R stands for reset. Q is output, and Q bar is complement of output. Okay, so I will give like this. Yeah, okay, I will give it in reverse way. I am going to explain about active high latch. So reset is there, set is there. Okay, so reset is given to a NOR gate. Okay, and you are getting the output Q. Here S is given to a NOR gate, and the output is Q bar. Now I am going to latch. That means this Q bar is fed back, and here this Q is fed back. Okay, so I am taking this as gate 1 and gate 2. Okay. Now if you are taking the expression of gate 1 and gate 2, what is the expression of gate 1? Gate 1, the expression becomes R or Q bar the whole bar. Is R or Q bar the whole bar. That is the expression of gate 1. Now what is the expression of gate 2? Expression of gate 2 is S or Q the whole bar. That is basically NOR gate. Now coming into operation. Now I am going to give now coming into operation of it. Okay, now case 1. Okay, so I will go to the next page. Okay, or I will write it here itself. In the first case, when S is equal to 0 and R is equal to 0. Okay, what is the output of gate 1? When S is equal to 0, R is equal to 0, what is the output of gate 1? Gate 1 is 0 or Q bar the whole bar. What is it? That is Q bar. That becomes Q. What is the output of gate 2? Output of gate 2 is S is equal to 0, so it is 0 or Q the whole bar. That is Q bar. Okay, so that is going on fine. You are getting Q and Q bar. Okay, now coming to the second case. Coming to case 2. In case 2, what I am going to do is, that means here Q and Q bar, that means there is no change. Whatever it is, it will remain like that. That is that here what happens is previous state is remained. Previous state is remaining. Now coming to the second case, I am keeping S is equal to 1 and R is equal to 0. If S is equal to 1 and R is equal to 0, what is the output of gate 1? If S is equal to 1 and R is equal to 0, if S is equal to 1 R is equal to 0, what will we get? 0 or Q bar, the whole bar. Again, what will we get? That will get the Q, no problem there. Whereas for gate 2, what will be the output? S is equal to 1, so it is 1 or Q, the whole bar. What is it? That is 1 bar. That is equal to 0. Okay. That means at this point you will get 0. Okay. Now what happens? The output of gate 2 is 0. That means what should be Q? Which means that what should be Q? This is Q bar. What should be Q? Q should be equal to 1. Which means that the output Q is set to 1. Okay. That is a case when S is equal to 1 and R is equal to 0. That is here Q is set to 1. Q is set to 1. But it is okay. Now again Q is set to 1. Okay. So that is set. Okay. So I think you got the point. Now coming into third case. I will draw the circuit once more. Coming into the third case, so we are having reset set. I am having a NOR gate. This is G1. This is Q. Here I am having a NOR gate. That is G2. This is Q bar. Q bar is fed back. Here Q is fed back. Okay. Now coming into case 3, third case. Case 3. I am keeping S is equal to 0 and R is equal to 1. Let us see what happens. S is equal to 0 and R is equal to 1. That is the third case. Now what is the output of gate 1? Here output of gate 1 will be S is equal to 0, right? R is equal to 1. So it is 1 or Q bar, the whole bar. What is it? That is 1 bar. That is equal to 0. So what is it? That is output of gate 1 is Q. So Q becomes 0. Now what is the output of gate 2? The output of gate 2 will be what? S is equal to 0. So 0 or Q whole bar. It is 0 or Q the whole bar. What is it? That is Q bar. That is equal to Q bar. So since Q is equal to 0, you will get Q bar is equal to 1. Okay. That means here what happens? The output will get resetted. This is getting resetted. Okay. And this is set. Set means it is the output is set to 1, and reset means the output is set to 0. Now coming to the fourth case. Case 4. Case 4, that is the last case. That is when S is equal to 1 and R is equal to 1. When S is equal to 1 and R is equal to 1, what happens? Okay. So what will be the output of gate 1? Gate 1 will be what? 1 or Q bar, the whole bar. That is 1 or Q bar, the whole bar. What is it? That is 1 bar. What is 1 bar? 1 bar it is 0. That is equal to Q. What is the output of gate 2? Output of gate 2 will be 1 or Q the whole bar. What is it? That is again 1 bar. What is it? That is 0. That is equal to Q bar. That means when set is equal to 1 and reset is equal to 1, you cannot make this. You cannot make Q and Q bar both as 0. That means this is basically an invalid state. Or what you can say is that the output is unpredictable. Okay. So now I have explained the 4 cases. Okay. That means here what happens is that when set becomes high, the output becomes high, and when reset becomes high, output becomes low. So that is why it is known as active high latch. Now if I am drawing a truth table, for this active high latch, truth table of active high latch, truth table of active high latch. Okay. So here I am having S is there, R is there. Now present state, what do we are having, and next state. Okay, I have this is present state going into next state. Now what is the definition in that? This is state. Okay, first case, set is 0 and reset is also 0, and if present state is 0, next state also becomes 0. That means here what happens? When S is equal to 0 and R is equal to 0, you will get Q and Q bar itself. That means previous state is remaining. So whatever is the previous state, it will come as next state. That means there is no change. Here there is no change. Now come in the second case. Second case is you are having set 0. What is the second case? Second case is set 1 and reset 0. Set is 1 and reset is 0. Okay. Now I am keeping present state as 0 and 1 here. No problem. Okay. And I am having two present states. It can be 0 or 1. Now in this case what happens? What will be the next state? The next state will be what? Because I am keeping set as 1, always the next output will be equal to 1. Okay. This here you get 1 and 1. Okay. So that is known as set. Next case. Next case is set is 0 and reset is 1 and present state is 0 and 1. So what happens? If it is 0 or 1, what happens? Then in the next state it will go to 0. That is this case. This is the third case. So that is reset. Now coming to the last case. What is the last case? When set and reset is 1, there are two present states, 0 and 1, and we cannot predict to which state it will go. So it is don't care. That means it is intermediate or it is invalid. It is invalid, or we can write it as intermediate state. Okay. So that is regarding this active high latch. Okay. So basically this active high set reset latch. Active high latch is basically formed on the basis of NOR gates. Active high latch is formed on the basis of NOR gates. Now coming into active low latch. Okay. Next one I am going to deal with is active low latch. Okay. Next one is active low latch. This one is active low latch. So what is basically active low latch? That means if something is initially high and then it is going low, then only the output will get triggered. So for this active low latch, I am having NAND gate. Okay, this is Q, and this becomes Q bar. Okay, so here Q is fed back to here. Here Q bar is fed. Okay. Now I am keeping this as gate 1 and gate 2. So here what is the output of gate 1? Here I am having NAND gates. So what is the output of gate 1? Output of gate 1 is S dot Q bar, the whole bar. And what is the output of gate 2? Output of gate 2 is R dot Q, the whole bar. Okay. Now I am going for the 4 cases. Come to the case 1. First case, that is S is equal to 0 and R is equal to 0. When S is equal to 0 and R is equal to 0, what is the output of gate 1? Gate 1 is 0 dot Q bar, the whole bar. What is it? that is 0 bar, that is 1. And what is output of gate 2? What is output of gate 2? That becomes 0 dot q the whole bar, that is 0 bar, that is equal to 1. So here actually what happens, this is q and this is q bar. See here what happens is q and q bar is exactly the same. That means it's exactly the value can be is same according to the relationship. So what does that mean? That means this is basically an invalid state. This is basically an invalid state. That means when s is equal to 0 and r is equal to 0, it is basically invalid state. Now coming to the second case, case 2. Case 2 is when s is equal to 1 and r is equal to 0. That is the second case. Okay, when s is equal to 1 and r is equal to 0, what happens? What is the output of gate 1? What is the output of gate 1? That is 1 dot q bar the whole bar. What is it? That is q bar bar. That is q itself. And what is the output of gate 2? The output of gate 2 is 0 dot q the whole bar. What is it? That is 0 bar. That is 1. Okay. That means that 1 comes back, and what happens to q? That means here this q bar is 1. Therefore, what is q? Q becomes 0. Here q bar is 1, and what is q? Q becomes 0. That means when s is equal to 1, that is getting resetted. Okay. When s is equal to 1, that output is becoming 0. Okay. So here what is actually happening? Here we are getting is reset. That means when set is equal to 1, you are getting output as 0. That is q as 0. That is known as reset. So whatever is the previous state, it is replaced to 0. That is reset. Now coming to the case 3. Write it here only. Okay. So this case is reset. This case is reset. Now coming to case 3. So what is the case 3? Now coming to case 3 and keeping s is equal to 0 and r is equal to 1. When s is equal to 0 and r is equal to 1, what is the output of gate 1? Gate 1 is 0 dot q bar the whole bar. Okay, what is it? That is 0 bar, that is 1. That is actually q. Now what is the output of gate 2? Gate 2 is 1 dot q whole bar. What is it? That is q bar. So here q is 1, and since q is equal to 1, q bar is 0. So that means it is actually set. It is actually a set state. That means output is set to 1. Now coming to the last case, that is case 4. Coming to the last case, that is case 4, that is s is equal to 1. S is equal to 1 and r is equal to 1. That is the last case. So here what is the output of gate 1? When s is equal to 1 and r is equal to 1, what is the output of gate 1? Gate 1 is 1 dot q bar the whole bar. What is it? That is q bar bar. That is equal to q. What is the output of gate 2? Output of gate 2 is 1 dot q whole bar. What is it? That is q bar itself. That means there is no change. There is no change. Okay. That means here what happens in the first case, when s is equal to 0 and r is equal to 0, the next state becomes invalid, because we cannot predict to which state it will go, because q and qr is equal to 1, which is actually impossible case. Next case is when s is equal to 1 and r is equal to 0. What happens? The q becomes 0 and q bar becomes 1. That means it is resetted. The third case, when s is equal to 0 and r is equal to 1, what happens? Q becomes 1 and q bar becomes 0. That is set. Now, in the last case, when s is equal to 1 and r is equal to 1, that becomes no change. Now, if I am drawing a truth table for active low latch, truth table for active low latch, here what happens? I am having set, reset, present state, next state, and what is the status. Okay. Since there are 4 sets of S and R, 1, 2, free. Present state can be 0, 1. Here also 0, 1, 0, 1, 0, 1. Okay. So coming to the first case is set is equal to s is equal to 0 and r is equal to 0. S is equal to 0 and r is equal to 0. That is first case. I am writing it twice because I need to have two present states. Present state can be 0 or present state can be 1. So here what happens, we cannot predict to which it will go. So that is basically invalid. Now next case is case 2 is s is equal to 1 and r is equal to 0. S is equal to 1 and r is equal to 0. And if present state is 0, it will go, okay. Now whatever is the present state, you will get 0 as output. 0 as next state. Okay. So that is, it is basically a reset. And if set is 0 and reset is 1, the next state becomes 1, right? When set is 0 and reset is 1, the Q becomes 1 or next state becomes 1. So that is, it is set. Now coming into next case, that is when s is equal to 1 and r is equal to 1. And s is equal to 1 and r is equal to 1, what will you get? You will get Q and Q bar itself. So then that means you will get present state is equal to next state. That is, here you will get no change. Okay, so I think you have understood what is the truth table for active low latch and active high latch. Okay, so in this lecture we have dealt with latch, where we have started. Latch is basically a lock, and lock means what a locking is. How we are getting the lock is whatever they are getting the present state. You may get change or you may not get change. Okay, or it may set or reset. That is known as latch. Now there are two. What is basically two types of latches? That is active high latch and active low latch. Active high means when the value of set or reset becomes high, it will act correspondingly. Okay. What is active low? When set or reset becomes low, it will act accordingly. Okay. Then such kind of latch is known as active high latch and active low latch. So generally, if you are having a latch, you are having a set input and a reset input, and the outputs are output and complement of output. Okay. So generally, you are having here, this is S and R, and this is Q and Q bar. Okay. Now coming into first example, that is active high latch. We have the example is with the help of a NOR gate, and I have explained the four cases here. And while we are drawing the truth table, here there are present state can be present state is 0, 0, because I need a 0 and sorry, here we will get 0 and 1. There's a mistake here. Here we get 0 and 1 only. There is no change. That means 0 and 1. Yeah, 0 and 1. That is no change. Yeah, that is when present state is that means when set is equal to 0 and reset is equal to 0, present state, whatever is in the present state you will get in the next state also. That means that is no change. If set is equal to 1, next state will be 1, and if set is equal to 0 and reset is equal to 1, next state will be 0. That is a reset. And if s is equal to 1 or r is equal to 1, we cannot predict to which state it will go. That is known as invalid. So that is regarding active high latch. Now coming into this active low latch, I have explained each steps. And here the difference is that I am giving present state and next state. Okay, present state is 0, 1, 0, 1, 0, 1, 0, 1. So I should start from present state and go to the next state. Okay, when present state is 0 and 1, my set and reset can be 0. But I cannot, in this active low latch, I cannot mention to which state it should go. So it is invalid. Again, if it is 0 and 1, and if set is equal to 1, it will go to 0. That is known as reset. And when r is equal to 1 and s is equal to 0, and if present state is 0 and 1, it will always go to 1 and 1 only. That is known as set. If both are 1 and whatever is the present state, it will come in the next state. That is known as no change. So hope you have understood what is done by active low latch and active high latch. Okay. So that was an introduction to latch. Now in the next lecture we will be going with gated latches, or that gated latches or clocked latches are known as this flip flop. Okay. So in the next lecture we will be having an introduction to flip flops. Thank you.